Okay, so what does Isosceles triangle theorem say? It says two things, that if you have two sides in a triangle that are congruent, right? So say, let's go in one direction, that side AB is congruent with side BC, then, right, you know that the corresponding angles must be congruent. Then this is congruent to this. Okay, now, again, the corresponding angle to this side is angle A, and the corresponding angle to this side is angle C. And again, if you have that the sides are congruent, then the angles are congruent. And the full theorem says that if the angles are congruent, then the sides are congruent. But you need to do one direction at a time. So we're going to just be given that the sides are congruent. Okay, so I'm going to say AB is congruent to BC. And what I want to show, I haven't shown this, that angle A is congruent to angle C. So let's prove this way first. So how do I prove this? Well, the first thing you need is, let's say, angle bisector axiom. And what does this say? This says something very simple. Every angle has an angle bisector. So then that means that angle B, right up here, this angle right here, has an angle bisector. So you want to say, by angle bisector axiom, we can draw the angle bisector of angle B, say BD. Okay, so we can draw in that angle bisector. Now, right, what is an angle bisector, right? So in order to understand this axiom, right, you want to say, okay, well, what's an angle bisector? An angle bisector cuts the angle into two congruent parts, or divides the angle into two congruent parts. So we're going to call the congruent parts angle 1 and angle 2. And by definition of angle bisector, angle 1 is congruent to angle 2. So we're going to state that theorem now. Or we're going to state that statement. Sorry, theorem. We're going to state that now. We're going to say that angle 1 is congruent to angle 2 by definition of angle bisector. By definition of angle bisector. Okay, so let's recap what we're doing. Let's make sure we understand. Okay, so we started off with just knowing that this was congruent to this, right? You say, okay, well, every angle, that angle up here, must have an angle bisector. So draw that angle bisector. Okay, then we know that by definition of angle bisector, this angle is the same as this one. Then what do we know? Let's finish it, right? This side is congruent to itself by reflexive, which means that this triangle, right, you have this side is the same as this side. And then you have that this angle is the same as this angle, and then this side is clearly congruent to itself. So this triangle, this whole triangle, ADB is congruent to CDB, right? These two triangles are the same, which means that each of the pieces, this piece is the same as BC. That was what was given. This angle is the same as this angle. This side is congruent to this side. This AD is the same as DC. That's also something that you could say, but it's irrelevant. What do we care about? We also could say that this angle is the same as this angle because they're the same triangle. But what we care about is to say that A must be then the same as C, and that's exactly what we wanted. Okay, so let's rewrite everything. Let's do it again. Okay, let's write it. We went over theory. Now let's rewrite it. Where did we stop? So we said, I think we stopped there. Now let's say, okay, so by definition of angle bisector. And then we're going to write down everything that we have. We have AB is congruent to BC by given. That's what's given to us. That's what we're starting with. And I want to write this down so I could show side, angle, side, right? By given. And then I also have that BD is congruent to itself by what's called reflexive. Reflexive is just saying every segment is congruent to itself. Okay. And then what do I have? Well, we should see. This is congruent to itself. This is congruent to AB is congruent. So this is congruent to this. That's what we're given. This angle is the same as this angle. And then this side is congruent to itself. We have side, angle, side. And the two triangles are indeed congruent. So we can say by side, angle, side, triangle, and we want to keep the order right. A, B, D is congruent to C, B, D. And then, since these two triangles are the same, all the corresponding parts must be the same, right? Since what is these two triangles are congruent, all the corresponding parts must be congruent. And A corresponds with C. Look, they both come first in the correct congruence statement. So you could say angle A is congruent to angle C by CPCTC. And CPCTC, corresponding parts of a congruent triangle are congruent. And now you're done with that direction. Now you need to do the other direction, right? Because it's an if and only if. The one direction is this right here, right? Now what's the other direction? The other direction is the opposite of this, the converse, I should say, not the opposite. Okay, if angle A is congruent to angle C, then we have that the corresponding sides are congruent. Okay, now let's prove this. Okay, and I don't even know, I don't remember. Let's draw the picture for that. So drawing the picture for that, I have these two sides. I don't know that they're congruent. And I know that A is congruent to C. Okay, and here's B. So what do I start with? I say every segment has a midpoint. Nope. I say that B has an angle bisector, and then I have angle, side. Okay, so again, similarly in this one, okay, you start off with saying that every angle has an angle bisector, just like in this one, or you could say it just the way I said it in the last one so that you're not confused. Okay, by angle bisector axiom, we draw BD bisecting angle B. Okay, so again, let's draw BD bisecting B. Okay, and then again, 1 is congruent to 2. And then now we have, okay, so we have angle 1 is congruent to angle 2, again, by definition of angle bisector. And then we can say that A is congruent to C by given. And where am I going with this? You don't know, because we didn't do theory first in this one. You should always do theory first by given. And then I have that this side is congruent to itself. BD is congruent to itself by reflexive. Okay, and then, right, what can I say? Well, what was the game in this one? This angle is the same as this one, this angle is the same as this one, and then this side is the same as itself. So by angle, side, the two triangles are now congruent, which means that all of their corresponding parts are congruent. So this line this line is the same as this line, because this triangle on the left is the same as this triangle on the right. So all the corresponding parts, this piece corresponds with this piece, or this part corresponds with this part. So then they must be the same as well, because ultimately this triangle is the same as this triangle. Okay? And let's finish this. So I have that the triangles are congruent by angle, side. Okay, this angle is the same as this one. That's what's given, right? This angle is the same as this one because I drew that bisector. And then this side is the same as itself. So I have angle, side. By angle, side shows that the two triangles are congruent. Triangle, what's ABD is congruent to triangle CBD. Okay, let's just make it by angle, side. Make it a little bit more clear. And then I know that all the corresponding parts must be congruent. So then that means that this segment, right, because AB come next to each other, it's in the 1 and 2 slot, must be the same as the 1 and 2 slot here. That means that they're corresponding. This means that AB is congruent to CB or BC, same thing. Okay, by CPCTC, and then you're done. Now this proof is done because you proved it in both directions. So you need to do two proofs if it's an if and only if, right? You need to go in the one direction. You need to say if the two sides are congruent, then this is true. And you need to go in the other direction, which means that if the angles are congruent, then these two sides are congruent. Okay? And we did it in both directions, illustrating the theorem.